NASA detected how a comet stops abruptly, and it's something that was never ever seen before, and they have a video of it explaining. NASA's Swift spacecraft, which has been in operation for over 13 years, has managed to capture an unprecedented change in the rotation of a comet. The images, which were taken in May of 2017, revealed that Comet 41P, Tuttle-Giacobini-Crescek, turned 3 times slower than it did in March when it was observed by another telescope at the Lowell Observatory in Arizona. And this is a really abrupt slowdown that had never been seen in a body of this type before, as explained by the researchers in the latest issue of the journal Nature, that the comet stops. The previous record of the rotation of the comet was 103P Hartley 2, which decreased its rotation from 17 to 19 hours for 90 days, says Dennis Bodwitz, associate researcher at University of Maryland in College Park, who presented the findings at the meeting of the American Astronomical Society in Washington. On the contrary, Comet 41P reduced it more than 10 times in just 60 days, so both the scope and speed of this change is something we have never seen before, he stressed. It went from about 20 to 60 hours, and then the comet stopped. Comet 41P orbits the Sun every 5.4 years, traveling as far as the planet Jupiter, whose gravitational influence has captured it on its current path. It's less than 1.4 kilometers in diameter, so it's among the smallest of the family of comets whose orbits are controlled by the huge planet Jupiter. Precisely its small size is what can help explain how it suffered such a drastic change. The comet stops. When a comet approaches the Sun, the increase in heating causes the ice on the surface to change directly to gas, producing jets that throw particles of dust and frozen grains into space. This material forms an extended atmosphere called coma. Water in the comet decomposes rapidly into hydrogen atoms and hydroxyl molecules when exposed to ultraviolet sunlight, a light that the Swift is able to detect. Terrestrial observations established the initial rotation period of the comet in approximately 20 hours at the beginning of March 2017 and observed its deceleration later in the same month. The comet passed 21.9 million kilometers from Earth on April 1st, and 8 days later it made its closest approach to the Sun. Swift photographed the comet from May 7 to 9, revealing variations in its light related to material recently expelling the coma, and these slow changes indicated that the Comet 41P rotation period had more than doubled, between 46 and 60 hours. Estimates of Comet 41P water production, along with a small body size, suggest that more than half of its surface contains jets activated by the sunlight. That is a much larger active fraction than in the most comets, which usually support jets only on 3% of their surfaces. We suspect that the jets in the active areas are oriented favorably to produce the torques that slow down Comet 41P turn, says Tony Farham, lead researcher scientist at UMD. If the torques continue to act after the May observations, Comet 41P rotation period could have been reduced to 100 hours or more at this time. And this is a video by NASA Goddard. This is on Infinity Explorers. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.